This comet has jets pointing toward the sun. On November 19th, NASA held a press conference to unveil the first close-up images of interstellar visitor 3I Atlas, captured by the Mars Reconnaissance Orbiter from just 30 million kilometers away. Associate Administrator Amit Kshatriya opened with an unusual statement. This object is a comet. It looks like a comet, behaves like a comet, and all evidence points to it being a comet. But what NASA didn't discuss were the three things French astronomers documented 2 days earlier: gas jets pointing in multiple directions, including directly toward the sun, a dust tail that's virtually absent despite intense gas activity, and a structure that remains stable for 24 hours, physically impossible for a rotating, outgassing cometary nucleus. The Mars images were supposed to settle the debate. Instead, they've intensified it. The high-rise camera aboard Mars Reconnaissance Orbiter has a resolution of 30 centimeters per pixel when viewing the Martian surface. On October 2nd, that instrument pivoted upward and captured 3I Atlas from 30 million kilometers away. The image shows a diffuse white blob, a fuzzy sphere of gas and dust, exactly what you'd expect from a comet. But two details are immediately wrong. The coma is asymmetric, and where there should be a prominent dust tail, that classic feature that has defined comets for centuries, there's almost nothing. MAVEN, the atmospheric probe, delivered ultraviolet spectra confirming hydrogen in the coma, also consistent with a comet. But the ratios are unexpected. Carbon dioxide dominance suggests a chemical composition unlike any Kuiper Belt comet we've studied. The European Space Agency's ExoMars Trace Gas Orbiter achieved something historic. For the first time, astrometric data from a Mars orbiter were accepted into the Minor Planet Center database. The precision of the trajectory improved by a factor of 10. We now know exactly where 3I Atlas is. What we don't understand is what it is. And as this story develops over the coming weeks, I'll be tracking every update. But the real story lies in ground-based observations. On November 17th, 2 days before NASA's press conference, French astronomer François Kugel published a high-resolution image of 3I Atlas, 22 exposures of 30 seconds each, combined into a single frame. What it shows shouldn't be possible. Anomaly 1. The jet geometry. The gas streams, called jets, point in multiple directions, not just away from the sun, as expected, but also toward the sun. One photo alone could be a projection effect, but Kugel's image from November 16th shows the same structure, stable over 24 hours. A cometary nucleus rotates. Different areas heat and cool with the rotation cycle. The jets should wander, change, appear, and disappear. On 3I Atlas, they don't. Anomaly 2. The missing dust component. Every textbook comet has two tails, a plasma tail of ionized gas pointing directly away from the sun, and a dust tail following the comet's orbit. On 3I Atlas, the dust tail is virtually invisible despite intense gas activity. The coma is bright, the jets are active, but the dust, the material that should be entrained, is largely absent. Anomaly 3. The energy balance. Here it becomes mathematically precise. The observed outgassing requires energy. To sublimate ice, sunlight must be absorbed. Calculations performed by USA Herald based on available photometry show 3I Atlas would need to absorb at least 3 times 10 to the 18th joules. For that absorption, the object would need a cross-sectional area exceeding 1,600 square kilometers. That corresponds to a diameter of 23 kilometers. Hubble Space Telescope data from August estimate the diameter at 4 to 6 kilometers. Even with optimistic assumptions about albedo and absorption efficiency, the equation doesn't balance. The comet is releasing more energy than it should be able to absorb. Either one of our assumptions is wrong, or 3I Atlas has an internal heat source we don't understand. NASA's November 19th press conference was remarkable in what wasn't said. Associate Administrator Amit Kshatriya opened with a clarification. This object is a comet. It looks like a comet, behaves like a comet, and all evidence points to it being a comet. An unusually defensive statement for a scientific press conference. Shane Byrne, principal investigator of the HiRISE instrument, framed it more scientifically. Observations of interstellar objects are still rare enough that we learn something new on every occasion. The explanation, early activity, already at 4 astronomical units distance, suggests highly volatile compounds, carbon dioxide, carbon monoxide. The dominant CO2 signature in the spectra confirms this. The unusual properties could be attributed to cosmic radiation that altered the ice structure over millions of years. An exotic comet from a foreign star system, certainly, but still a comet. 48 hours later, Avi Loeb of Harvard University published his response. The title, there is nothing more deceptive than an obvious fact, a Sherlock Holmes quote. Loeb lists 12 anomalies, not speculations, but measurable deviations from standard cometary behavior, the energy balance, the jet stability, the orbital geometry. His central question, how probable is it that a random interstellar object arrives on a trajectory that passes 4 inner planets with an inclination of 175 degrees to the ecliptic? 1 in 100,000, Loeb calculates. If 3I Atlas is a natural ice ball, as NASA claims, Mother Nature was at least 100,000 times more generous than would be expected from a random delivery. NASA scientists haven't publicly responded to Loeb's blog post. That's unusual. During the Oumuamua debate in 2017, there were immediate counter-arguments, scientific papers, public statements. This time, silence. The debate won't be decided by blog posts, it will be decided by data, and the next few weeks provide the final opportunities. On December 19th, 3I Atlas reaches its closest approach to Earth, 269 million kilometers, still nearly twice the sun's distance, but close enough for ground-based telescopes. It's the last chance for amateur astronomers to observe the visitor themselves. More importantly, the James Webb Space Telescope will point its infrared instruments at 3I Atlas in December. Not for images. Webb isn't a camera system in the conventional sense, but for spectroscopy. The question, which molecules are in the coma? Carbon dioxide and carbon monoxide. We know, but are there more exotic compounds? Organic molecules suggesting an unusual formation history? Or, and here it becomes speculative, molecules that shouldn't occur in natural comets? Webb can answer this question. The resolution of the mid-infrared instrument is precise enough to identify even trace gases. When those results come in December, I'll break down what they mean for this debate. In spring 2026 comes the Jupiter encounter. A preprint study suggests that the gas giant's gravitational force could significantly alter the trajectory, the final deflection. After that, 58 kilometers per second toward the constellations of Gemini and Orion. In 8,000 years, 3I Atlas will pierce the Oort cloud. Then it's alone in interstellar space again. For millions of years. There's an irony in this story that extends beyond 3I Atlas. We've observed 3 interstellar objects. Oumuamua in 2017, a cigar-shaped tumbling object with no visible coma, yet showing non-gravitational acceleration. 2I Borisov in 2019, a textbook comet that behaved as if it came from the Kuiper belt, except it didn't. And now 3I Atlas, looking like a comet, mostly behaving like a comet, but showing details that don't fit the pattern. 3 visitors, 3 completely different profiles, no pattern. Statistical projections from planetary scientists suggest that millions of such objects traverse our solar system at any given moment, most too faint, too distant, or on trajectories that never bring them near our telescopes. We only see the exceptions, those that become bright enough, come close enough. What does it say about the diversity out there when even our 3 samples show no similarity? NASA calls 3I Atlas a comet formed under alien conditions in another star system. Avi Loeb asks whether our categories, comet, asteroid, spacecraft, might be too narrow for what exists between the stars. Both could be right, or both could be asking the wrong question. Perhaps the real lesson isn't what 3I Atlas is, but what we're willing to see. NASA scientists in Pasadena see data explainable by known physics, exotic but not inexplicable. Loeb sees the same data and asks why we don't consider the more extreme possibilities. This isn't a question of right or wrong, it's a question of scientific methodology. How many anomalies does it take before an object stops fitting our categories, and who decides where that line is drawn? The Webb data in December will answer some of these questions. Others will remain open until the next interstellar object arrives. And there will be a next one. ESA's Comet interceptor waits in orbit, ready for the right candidate. The Vera Rubin Observatory, once fully operational, will survey the sky every night. When the next interstellar visitor arrives, you'll want to be here for the analysis. The next object could be anything, a comet like 2I Borisov, an enigma like Oumuamua, or something entirely new that makes our debates about 3I Atlas seem trivial. Until then, we have these 43 days of data, these Mars images, these unexplained anomalies, and the unanswered question, why is NASA silent on Loeb's calculations?